we want to now check whether these ones are available or not available. So we want somehow to write available or not available in front of these ones based on their availability or non-availability in this library. So this code we have there is going to do just that. First of all, we create an empty, after we have created an assignment, giving an identifier to each of the two lists. So you remember from last week that this arithmetic assignment creates a reference to this list and calls it AutoSlide. And you remember that we found out how we can properly name identifiers last week. Several of you created identifiers that are correct. You also knew how to create identifiers that are erroneous. So, and the reason why you created identifiers that are erroneous is so that you will not create such identifiers. So you know AutoSlide now is a proper identifier. My list is another proper identifier. So this one references this list. This one references this list. So from that point on in the code, when we want to talk about this list, we just call AutoSlide. When we want to talk about this, we call my list. That's all. That is all that is happening here. Now, by line 16, we are just creating an empty dictionary. The empty dictionary is where we are now going to place all these things here and not just place them directly. We're going to place them in a table form. That is, each one of them will not just come on its own. It will come with whether it's available or not available. And in order to do that, we are going to iterate through my list. We are going to pick what is available, what is in my list one by one. So this statement creates an iteration through my list. So the code that is below it are going to be done by taking the authors one by one in my list. Because it's a list, we cannot guarantee which order. It will use whatever order it feels like, but it will take all of them one by one. Because we can iterate through this list. Like when I say iterate through the list, I mean we can pick the members of the list one by one. The one we pick, we name it auth. So if we pick Olabode, at that round, Olabode is auth. If we pick Yopi, at that round, Yopi is auth. If we pick Adamu, at that round, Adamu is auth. If we pick Shoyinka, at that round, Shoyinka is auth. So and it will do it as we go through, as we iterate through this list. So a list is therefore a set. This set is an iterable. A set is an iterable object. So my list, which is this set, is iterable. So we are iterating through it. So as we pick one of each one, so the one we have picked, we are now going to check whether it is inside this library. If it is available, then we are going to now say so. We are going to say my dict indexed with the particular author. So if it was Olabode, it would be my dict Olabode is available. If it's not available, if it didn't find it here, it would say my dict Olabode is not available. By the time it does that one by one, it will have populated this by dict. It populates this by dict, and it will have answered the question whether we can create a dictionary that will now show us how this is done. So this is the code that does it. You can see this is the for loop, and this is the if block in it that checks for each particular one, whether it's there. If it is there, it will say so. If it is not there, it will say so here. Now, so two things we need to know here. Number one, this may make sense to you, and you may think it's simple, but don't just assume. Type it in, work it out, make sure you get the same results we have got, and then go create problems that are similar to this for yourself and create even something more interesting. But don't do that until you have, first of all, run this code, you have understood it, and then you might be able to write similar programs. There are small programs you are writing. By the time you understand all these small programs, then we come back again and study all the elements that make those programs work. You then are learning how to program. Then by the time you are going to learn to program by actual programming. If you do not do it, if you just shake your head like a lizard, don't do your head like this, you are not going to learn anything. You must type these things in, make sure you make your mistake, make sure you correct all your mistakes. And sometimes you may make a mistake, you may forget a comma, you may forget a quote and all those ones. That's part of your learning process. You must. And then you see all these comment statements, which some of you asked about last time. These comment statements are statements to yourself to just tell you what's going on. The interpreter of Python, it ignores all those green lines that begin with a pound sign. So don't worry about them. But it may be useful for you to know what's going on. If you do all of this, then you are able to continue. And then once you finish understanding this, you can now write similar code for yourself. But instead of just looking at it here, I'm going to run in code through the debugger. So let us go to the code now. I think this is it here. This is the code. I hope you can still see the code. Admin, can my system be seen? I want to stop debugging here and restart this code. Admin, I'm waiting for an answer. Can my screen?
No, sir, it's still on the slides.
Well, there is a lot
yes,
of...
we have to wait for it because it's showing here. I'm seeing it. From that. Prof, it's like your screen, you've taken it off. Okay, it's on now. Is Prof muted?
I'm unmuted now.
Okay.
Okay. Is my screen seen by everybody now? I'm looking at my code screen.
Yes, sir.
Yes.
Okay, so good. So if my code screen is so I want to start debugging this code. Before I start, I first of all create a breakpoint at the beginning, at the end. So it is important to do that. So if I create a breakpoint and I say start debugging, and I say Python 5 debug the current, from there you can see in the variable section, you can see authors lib now has already gotten all those names. You can see it. And I can see there's an error here. There's an error here. If you look at second to the last thing there, you can see Shakespeare Milton. What wasn't intentional? It is coming from the fact that I forgot to put a comma between Shakespeare and Milton. So that is the advantage of looking at things in the debugger. So I am coming back here now. I'm going to correct that. And I put the comma there. And I will save. I'll save and restart. When I restart now, I'm going to go back again. So when I do that, you can see now there's no Shakespeare Milton again. You can see Shakespeare and Milton are now known to be two different authors in this. So this authors lib set this authors lib identifier has been used to reference this set. So the same thing is going to happen here. So if we do that again here, you can see that if we go to you can see my list here. My list here has the variables, 13 variables, 13, those are the 13 set elements, Adichie, Soyinka, and so on. You can see that the order in which he's putting it is not necessarily the same as the order I put it, because the list does not promise you to use the same order that you have used. So that is it. So these first two statements, the statement on line 2 and statement on line 8, they are essentially a single line statement. We just use the commas to put them on several lines so that it will not be too long. So those two statements have identified the two sets with authors lib. So the next statement, which is statement on line 16, is creating a new dictionary. The way you create, one of the ways you can create a new dictionary is by a beginning brace and closing brace. That creates a dictionary. You don't create a set that way. Just know, you don't create an empty set that way. It's only an empty dictionary you can create like that. If you look back into the previous code, you will see how to create an empty set. So from line 17, we are now iterating through the second list. We are iterating through this list. And when we are iterating through this list, let's see what we do in that iteration. The first line is that we pick one author. Let us say which one is picked. So the author that is picked will be the value of the author variable. Let us see whether that variable is out there, whether it is. Now, the first author picked is Adichie. Now, you can see that Adichie, in either the number one or in any of the two, you can pick them at random. But what you can guarantee is that it's going to take them one by one, and it's not going to repeat. It's going to take them one by one until it's done. So it picks Adichie, because Adichie is now the value of the variable author here. You can see it when we are there. So it's now going to check whether Adichie is in author's life. Remember that author's life is this list. So it's going to check. Even without the Python, you can see that Adichie actually exists in this place. So this is it. So you expect that this if here is going to be true. So it should say my dict Adichie should be available. Let us see whether it will succeed in doing that. So it says so. He said, okay, let's go and look at the list, the dictionary by dict. So you can see my dict here. My dict here has Adichie and is available. So it has done exactly what we expect. So let us see the next one. The next author picked. The next author picked is Soyinka. Is Soyinka available? Yes, Soyinka is available. Let us see whether it will do. Let it do this to go, and let us see in dict now. It says Soyinka available. Okay, so let us go on. The next author picked. What is the next author picked? Is Olabode. Olabode is Olabode in the library list. 1, 2, 3. I can't see Olabode there. So you will see what then will happen. Since Olabode is not, so you can see by the time you run this if statement, it bypasses the statement immediately after the if, and it goes to execute the statement in the else. So, and the statement in the else is not available. So if we finish that, let us go to the list that is being populated now, the dictionary that is being populated now. So you can see Olabode is returning not available because it's not available. So you can go on now. What did he do next? Achebe is available. See, Achebe is available. So you can see that time the next one is Bronte, not available. Bronte not available. Lotto not available because even though Lotto is in my reading list, Lotto is not in the libraries list. Okay. The next thing is Yopi. Yopi is in my reading list, but it's not in the library list. So it continues like that, and Mu not available until it has gone through the entire list. But it's creating here a dictionary. So this is one way to create a dictionary. And this code does it. You can run it through. And if you continue, you can run to the end, it will even print the list. It will even print the thing on your output. So you can see Adichie available, Soyinka available, Olabode. So it does that print here. So, or it can show it to you in the debugging window. So whichever one, you can see that when you run your program, if you write a print statement, the result of the print statement will occur here. But most of the time, you don't even need a print statement because the debugger usually will give you in a very, very nice form all the information you need to have about any variable that is explicit. But if a variable is not explicit, you may now have to write a print statement there. So that is this one. So that explains to us the first code. So let us now go back to what we were doing before.
There's a quick question in the chat.
Okay, you want me to answer it, or you want to?
Yes,
okay.
It's just on this code. Okay, it's a simple question. just for the sake of the class. The question is, why include line 28? Why do we need a pass on the...
Okay, that's, well, the thing is that I want to hold the, if I don't, well, it's a but it is this. Why can't I refuse to answer that question? Remove pass from your own and see what will happen. Because answering such questions seems to show that you don't know what I'm asking you to do. You go and run the code, and you should be able to answer me. If you're able to answer yourself that question the next time around. So you remove the pass and see what will happen. Because I don't want to be answering this type of question. The question, because let us say the kind of questions I want to answer is that you've done it and you are confused. But the way the question is stated right now is that you have not tried it. So why can't that be the incentive to go and try and see what will happen? What do you think?
Maybe the person might rephrase, because from the question, I don't know whether he tried it, and so maybe we get the question rephrased. Yeah.
Let us
so
see.
Maybe remove the pass and.
Have you tried the code? Have you removed the pass and run it? Because your computer will not explode if you remove the pass and run it. And if there's any, so for you to check, because I want you to try this thing. Not trying it and asking and getting your questions answered is not very helpful. You go try it, and then if you are still having difficulty, then you can ask a question. Because, for instance, it should be obvious to you that I would not have a place to put my break if this pass was not there, and you will not be able to see all this intermediate, because the code is still running. That's why you have this window. If this pass is not there and there's no break there, the program would have ended, and you would not be able to see all these intermediate results that I'm showing you. But you don't take my word for it. Go check it out. Okay, I think I want to move on. Okay, so let us go back again now to this. Okay, so let me wait a minute to be sure that you can see my screen. Can you see my screen now? I'm back to exercise 05. Okay. So, Dr. Adewobi, please unmute yourself so that you can let me know.
Yes, I can see. I can see it.
Yes, please, if you are muted and I'm asking a question and you cannot quickly unmute, just throw something in the chat so that I will know. Because I'm waiting to hear, or even Toby can do that. Toby, please give me a feedback. When I ask a question, can you see my screen? Let me know. If you cannot talk, throw something in it. You can see the screen. The screen is now back to the slides. Okay.
Yes,
so we can go. I'm now on slide. I'm now on exercise 6, looking at another. This is essentially the same code used for something else. In this particular code, we have two lists or two sets. One is science greats, great scientists. Some of them lived before the Nobel Prize was issued. And then the second one is Nobel laureates. So not all the great scientists are Nobel laureates. So what we want to do is that we want to check all the great scientists and check out which of them is also, in addition to being a great scientist, was also a Nobel laureate. It's exactly the same kind of logic that we have done. Again, I have this code covered. So let us go back to something. So that is a Nobel. Yeah, this is the same code again. Let me stop the debugging we were doing before, and then we'll go through again, you will see that I put a breakpoint at the beginning, and I put pass with a breakpointer. To answer your question here, if I didn't have this pass, which a pass is a completely redundant statement, but it's a statement, therefore it can hold the breakpoint there. If I don't have it, I won't be able to put this breakpoint here. So if I were not teaching, I wouldn't have used this pass. I'm using this pass to help me to teach you. That's all. So if you start with this, after you have put those 2 breakpoints, you can again start and say, start debugging. So with this debugging, we start here again. And again, this is a longer list. And then it will, first of all, again, it is associating this set with the identifier great scientist. So it has done that association, and you can see it here. So all of them are here. You can see, I can see errors now. I can see that Lord Rayleigh and James Clerk Maxwell, those are 2 names, but I can see that James Clerk Maxwell, let me see James Clerk Maxwell. It must mean that I didn't, okay, this is Lord Rayleigh here. There's a comma missing there. Then that must be John Williams Trott. Where's John Williams Trott? Okay, that one is okay. Okay, so everything else is okay. So I want to say again and restart. Okay, so you can see how we handle simple errors. Computer miss, because it's not an error of syntax, it's an error of logic because I forgot that comma. When you forget a comma in strings, it just joins the 2 strings together as if it's Clerk Maxwell are now seen as different. They are seen as different names. Okay, so we have those, and so we can move on now. We have the list here now. We associate that with Nobel laureate, and then we create again my dict. Then we're now taking the scientists, great scientists, one by one, these great scientists, and then we are now creating a dictionary based on, in this particular case, we create a dictionary if it is a Nobel laureate or simply great. That is, it is a great man, but he was not given a Nobel Prize. So we can now go through that and you can see. So if we do that, let us see my dict now. My dict here, for instance, Robert Boyle, we worked before Nobel Prize was being given. So Martin Gottin worked after, but he didn't get a Nobel Prize. Albert Einstein was a Nobel laureate. And Ambius Avogadro, who was equally great, was just simply great. So these are the things we are able to do as a result. But right now, it's considering Leonhard Euler. Leonhard Euler is the current one that has been taken through this iteration. So he's going to check whether Leonhard Euler is a part of the Nobel laureates. He probably will find that it's not. So he's going to come and say simply great there. So Leonhard Euler is simply great. So it goes through all of that. So you try this out and be able to write similar code for yourself. And then you'll be able to understand how dictionaries can be created, how they can be used to actually index and to actually annotate the value here by giving, choosing whether they are simply great or just Nobel laureate. It could be more, you could have more things to write about them, but that's what we want to do here. So we have looked at those 2. So let us move on now. Okay, so aim here, given 2 sets, find the membership of items of one set in the other. We use the dict collection to achieve this. That is so the dict is another kind of collection. In the dict, there is a key that is matched to a value. We can create an empty dict by simply creating an empty brace pair. To add values to a list, we simply take the name of that list and assign a value indexed at the appropriate key. So when you want to add something to a list, you take the name of the list, you index it with the appropriate key. So in this case, we have said that it is scientists we create here that we're going to use to index, and then we now attribute a value to it. So if you do that, our exercise is to take each of the items in science grade set and check it against the Nobel laureate set. In fact, it is an interesting thing to do the opposite. Why don't you start with the Nobel laureate and then check in the great scientists? So just the opposite and see what will happen. It is those kinds of playing with these things that show you how to program. So if you understand this code, what you do is that you come back there again and you are going to make some changes and see whether the kind of results you expect is what you get. That way, you will be learning how the dictionary works, how the for loop works, and how the if-else block works. We will discuss this thing in greater details later, but just practice these simple examples. And these simple examples will give us the fodder to really use to discuss them in greater details. If you are discussing them academically, just theoretically, you cannot understand them as deeply as when you have played with them and you understand how to, and you have been using them. So suppose we have a set of great scientists. We also have another set of Nobel laureates. Our exercise is to take each item in the great scientist set and check it against the Nobel laureate set. And the dict is used to record if a particular scientist won a Nobel Prize or is simply great. Build a complete list. So you can change this now. You can go to the dictionary, Google it. You can build your list of Nobel laureates to be much bigger than this. So you can build it to be maybe several pages of Nobel laureates that are in Wikipedia. And then you now have a much more robust list. Those are things you can do. So you can build the Nobel list in physics from this site if you're interested. This is a site where you can get the Nobel laureates in physics. What can you do with it? So this is an example of the use of the dict. So what do I have next? Now we get to Venn diagram. Those of you who have done set theory already in school, you know you create Venn diagrams, in which case you have, for instance, you have this set, great scientists and Nobel laureates, and then there are some names that are here, there are some names that are here, even though we expect each set to be independent, but the two sets have some things in common. If you now draw your Venn diagram, you will see that the things that are in common will be in the intersection. In this particular case, the Venn diagram that we have created here is just going to put the numbers. But we will, because we have the code, we have ability to write code. We know there are nine here that are in the intersection. What our code will do, it will print those 9 names. That is something you would have to use your eyes to just check, but the computer can do that much more efficiently. So we can go ahead now. Again, as before, I'm going to take you through the code here. And let us see how the code here runs. This is the code. The first thing you will notice is that there are 2 lines here, numbers 1 and 2. There are library functions that are not part of the Python, which is in the library. So you have to import them. And this is one way to import them. This is not the only way, but this is one way to import them. So you import this, you import on these 2 lines. If these 2 lines are missing, the code will have problems. So just know that. And that is why when you were beginning, we made you load the matplotlib and portion. So those things will now begin to become useful. Again, as before, we're going to stop the debugging and start all over again. So if you stop this debugging and then we start the debugging again, and we say debug the currently active Python file. So let us see what happens. So it is starting from here. You know, as usual, when you go line by line, it's going to first of all look at all the elements in this. When it has finished, it's going to associate it with the science grades as before. Okay. From then it goes again. Nobel laureates is associated, and then it's now here. There are two things in the Venn diagram. The first thing is to declare all the things you want in your Venn diagram. Number 1, when you want to do a Venn diagram, you have 2 sets. This is one set and this is the other set. So the first thing is in this list that starts with opening bracket to close bracket, you put the sets that you want to do a Venn diagram on. and you put a comma. The next thing, if you have labels you want to use for the sets, you put the first one, we want it to be Nobel laureate. With no abbreviation, we can write as long as we like here, and then great scientist instead of science great. Because the reason for this, you don't need to do this. If you didn't do by the here, name you put here is any name you like. You can have spaces. You can do. You are no longer under any. In creating your labels, it doesn't have to obey the rules of identifiers. So that is the advantage of this one. But if you're happy with your identifiers, no problem. So once you have done that, in parentheses, a list in parentheses, you put a comma there. You can also set the colors. Now we decided to set colors yellow and red. So since there are two of them, and then we also set the transparency so that one can be seen through the other one. So all these things are things you can play with. So this statement on line 29 to 31 is just giving us how we want the Venn diagrams to be drawn. Then line 32 is that the Venn circles should be constructed. So the line 29 is telling us, giving us all the settings we will need, and the line 32 is what is actually doing it, and 93 is what actually now shows us. The fact that it does it doesn't mean we'll see it. It's line 33 that makes it possible for us to see it. So let us run through those lines now. So that one is the setting is done. And now, if we run the plot show, immediately after doing that, what happens next is that you will see that there will be, okay, let me see whether I have to go one step further. No, it's not, it's still doing it. It's taking time. Could be because I didn't know that it takes this much time. This is surprisingly long because when I ran this program earlier, I didn't have to wait for it for this long. So I'm not sure what's going on here. Cool. Well, I am not ready to wait this long, so let me run this thing again. And instead of that delay, I'm going to put a breakpoint there and run it to that point straight away. I'm still waiting to see, because it will be interesting to see this one work out. There's something here.
Prof, did it by any chance open somewhere else down your computer? I had a similar experience, and I found out I opened that figure somewhere down my computer.
Okay, because I ran it before the class. It will run without any problems. Let me just wait 1 more minute. Let me just wait 2 more minutes. And see whether it's just.
Okay, Prof.
Okay. Let me stop debugging and do it again. Okay, let me just do it one more time. And if it doesn't work this time, then we will. That example comes up again in some other things that we can see it. We have to check why it is, why this is misbehaving. Anyway, I will leave this one. Maybe I'll come back to that later on if it is not allowing us to move, because we can't wait at infinity for it. Go back again to this is the kind of result you are supposed to get, and so this is the kind of result you are supposed to get. Then in the next statement where you have the intersection, it's supposed to give you a list of the things. It's supposed to give you a list of the things that's intersect. Let's do another example. Is exercise 8, and maybe this one is a shorter example.
It looks as if I can see that a figure opened down on your computer.
Yes, it has worked. It has worked. It just a long time. It has worked. Okay, so we're back again we're back again. It's just very slow. It's very slow, but it's worked after some time. Just trying to see it. Okay. Okay, so this is it. This is the Venn diagram from this that comes from these two, coming from these three statements. Remember, these three statements are, in the first statement, we specify all the things, we specify the two sets that we want to do. We specify the set labels. You can see Nobel laureates, that is here now, that is the name of this set. Great scientists, that's the name of this set. And then you can see that we are using circles. We can use some other ways, ellipses and some other things can be done. And then when we say show, remember that we also included an alpha, which is a transparency. So you can see, because of that, even though we use two colors, where those colors mix, we can see the mixing. So give us the intersection. So you can play with this thing, change the value of alpha, and use different colors, yellow and red. Like yellow and red were used there. You don't have to be limited to yellow and red. So you can see you have a lot of things you can make choices about. And the next thing is the intersection of the list. Like if we turn the, so in order for the code to continue, in order for the program to continue, you have to close the image. If you close this image, you can see immediately it gets to line 34. It shows you that it's on line 34. And there you are now going to see the intersection between the science grades and the Nobel laureates. So if you run that, it gets to pass. Then you can look at your watch list. Well, it's not giving me the things I want, so I can go to my variables. My variables here, you can see that the intersection list. Let us look at the intersection list. To get intersection list, you can see that if you remember in the intersection, it just told us there are 9 names in the intersection. But our code not just gives us there are 9 names, it gives us who those 9 names are. So in your program, you can achieve more results than what not just a matter of numbers. It's telling you, you can see that these are the names that are common to these two sets here. That is the intersection of the two sets there. And that's it. So from there, we can go to the next code. In the next code, we are doing similar things. Here, you have, again, the first 2 lines, matplotlib, this importation, pipe plot, and so on. And then here you have authors library, Fagbua, Achebe, and Co. Something we have done before. And then we are now saying Venn diagram 2. We're using basically the same thing, using yellow and red, using the same alpha. That is the alpha here, as I said earlier, is the transparency list, the transparency value. So you can use anything from 0 to 1 here. Okay, so you check it. Don't ask me whether 0.7 or 0.5 will be better. You ask yourself, and you do that, change it, run it again, and see how it looks like. This will likely be a faster code because the sets are smaller. So if I want to run this one now, the first thing is I first of all stop debugging. After I've stopped debugging, I can now say start debugging, and then I say I want to debug the code inside the active code. So I can go line by line again as before. Go line by line. And then I'm defining my Venn. Then I want it to draw my circles. Then I want it to be shown. So when it, let us see how long it will take now for this one to happen. Oh, it has, okay. So these things were actually happening behind. So you watch out because the thing might be happening behind your screen. So here is it this time. There are 4 of them. And you can see the 4 are Wakwo, Adichie, Shoyinka, and Achebe. That's the one that is common to the reading list as well as my list. So we have showed 2 examples here. You can practice with those 2 examples and you will now eventually see how these things work. So those are the examples that, like I said before, let's see what the time is now. Our time is 7:49. We are going to go on break now. When we come back, we're going to be looking at comprehension and interval sets when we return. So break now for how many minutes? 15 minutes till 8:05. So we meet again at 8:05.
Yes, sir.
Welcome back from break. I hope we can continue now. Okay, so we are now going to look at set comprehensions and interval sets. For terminology, we are going to look at the difference between when numbers are taken as integers and when they are floating point numbers. For example, the first 21 positive numbers starting from 0 are members of the set post integer, 0, 1, 2, 3, all the way to 20. These are 21, there are 21 numbers there. And that is they are all integers. Now, if we want to look at all the real numbers between 0 and 20, there are certainly more than 21. Because, for instance, 0.5, 3.7, 9.003, all those numbers are called floating numbers. So numbers such as 4.25, 19.6, 2.85 are known as floats. Whereas the ones that are just supposed to be integers only are called ints, I-N-T. F-L-O-A-T, float. Those are keywords that are known to the Python script. Now, when you are interested in floating numbers in a range, there are 4 ways you can have them. You can look at, for example, if you say 0 to 20, that is the open range. X is greater than 0 and less than 20. If you say 0 to 20 with a square bracket at the 20 side, then you are saying that the value 20 is part of the interval. In the first case, 0 and 20 delimit the interval, but they are not part of the interval. In the second case, 0 and 20 delimit the interval, but 20 only is part of the interval, 0 is not part of the interval. In the third case, 0 and 20 delimit the interval, 0 is part of the interval, but 20 is not part of the interval. In the last case, 0 and 20 delimit the interval, and the interval contains both the 0 and the 20. So mathematically, we call this one a closed interval. We call this one an open interval. The intervals between are mixed because this one is open at 0, closed at 20. This one is closed at 0, open at 20. And these are the meanings of all those things. And this is, again, how Python will write it for you. When Python writes this for an interval, this is what it means. It means values taken from 0 to 20 without 0 and 20 being part of the interval. So we say this is an interval with its boundary not counted as part of the interval. Here we have an interval with the boundary counted on both sides as part of the interval. So that is the terminology. That happens when you are looking at intervals. So our set, the ability to do sets here is not limited to set of things. It can be limited, it can come to set of numbers, and we can decide to have set of integers as well as set of intervals. So we need to understand this. How do we create? We can create numbers this way. We can also create numbers through set comprehensions. Some libraries we install at the beginning of this course, such as Matplotlib library, Matplotlib library, Venn, and Portion. These provide facilities for dealing with graphics and interval sets. Comprehensions themselves are built into Python programming language and can be constructed with the basic installation without needing to import modules containing new libraries. In the ensuing code, we generate positive integer as well as the intervals we have previously described. The code went further to check the sets for membership of specific elements. On the right-hand side, the debugger variables analysis, analysis shows some of these results. So let us look at this code fragment here, which is a working code you can run. If you import Portion as interval, that is, the Portion library is imported, but we call it inside this program, we call it intvar. So when you say intvar, it means the Portion library. So that is the meaning of this construction. You can import Portion and call it Portion, but you can import Portion and call it another thing. But that other thing you call it must have all the characteristics of an identifier. So similarly, you import from Venn diagram, you're importing, and from Matplotlib Venn, you're importing Venn2 circle, and so on. And then you also, from PyPlot, you are importing PLT. That is what has the ability to show you your plot. If you don't have this, your plot will be there, but you will not be able to see it. Now, imagine, instead of writing 1, 2, 3, we can use this construct to create I for I in range 0 to 21. The range function starts from the beginning point and starts just short of the last point. So that is how the range function works. Now, you wonder, why would we say I for I? Because we are free to use, for example, if you say 2I for I, it will take 2 times 0, 2 times 1, 2 times 2, 2 times 3, 2 times 4, and so on. So if you say 2 times I, if you say I squared, then you have 0, 1, 4, 9, 15, and so on. So this I for I, it doesn't have to be I for I, it can be I times I for I. So it can be so many things you can do here, but this is the simplest way you can do the set comprehension. Again, the set comprehension allows you to do it in an interval, but don't forget that when you use range, you will not reach the last point. You will be shy of that last point. So just bear that in mind. Similarly, these are for generating discrete numbers. These two generate discrete numbers. This 6, 7, and 8 generate floating point numbers. So you just specify this range. So you have a closed interval 0 to 20. So that means that it will have 0 and 20, and both 0 and 20 will also be part of the set. You can test this by checking whether 20 is in this interval set, and the answer should be true. Now here you have open, close. If open starts, that means that it is open on this side and closed on the other side. Then the last one, okay, again here is closed. You could also have closed open. If you have closed open, then that means that it is closed on the first side and it's open on the other side. You have to test some of these things out to see. Now, in line 9, we say answer 5.5 in interval set 2. So this is an operation. Like checking whether 5.5 is inside this interval, and it should return true or false and assign that value to answer. Similarly, this one will perform the intersection between these two sets and check whether 18 is in the set created. If it is true, it will put true in test. If it is not, it will put false in test. Those are the things that will happen here. And then after that, you are now able to use the values of the comp set 1 and comp set 2 to create Venn diagrams the way we have been doing. Hension 1, Hension 2 at the two set comprehensions. These are the set comprehension 1, set comprehension 2, yellow and red. Well, there's nothing fetishy about yellow and red. They're just the colors that suited my fancy when I was writing this code. You can use any colors you like. And there's nothing fantastic about using 0.8 as the alpha value. You can use any alpha value which tells you about the opacity of what you are doing. 0 to 1. I think by the time it gets to 1, it is completely opaque. With 0, it is completely transparent. So you can have this too. And then you can show the plot. I think I also have this already covered in the code. So let us look at the code and run this. Let us run this code again. Never get tired of running your code. Just run your code as many times as you like. So the code there is in this. This is the code that we just looked at now. And then we can start again by saying stop debugging. And then I've already put a breakpoint at the beginning and the end pass here. And I can now say, okay, start debugging. So we'll start debugging this. Okay, it starts with that. And you can be checking the variables here. So if you go, these first two things just simply create your, allow you to use the library function. So comp set 1, this will show you what we mean here. So you can see comp set 1 gives us 0, 1, 2, 3, and you can see that it ends at 20. If we want it to end at 21, then we must put this as 22. You can check that out and get used to the way some of these functions behave. Similarly, if we run the next one, it gives us comp set 2. And let us see what comp set 2 is. Comp set 2 starts 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Shy of getting to 27. That is how the range function works. So now that is for the discrete numbers. Now for the interval numbers, which are floating values, the interval thing, which is now the portion, creates such intervals. And when you create the intervals, let us see what we to show. Now, in this particular first one, we want it to be a closed interval. So let's create it. Let's create it and see what will happen. So interval set 1, okay, interval set 1 is 0 to 20. You can see that it is closed in both beginning as well as the end. That is why it has square bracket here, a square bracket there. You can also check that, you can also check and find that 20 and 0 are actually members of this continuous set. So next is the open close. You can see that it's open at 4 and close at 27. So you can also check that again. And then the next one is close at 13 and 35. So we can test whether 18 is in the intersection of these two sets. This comp set 1 and comp set 2. So this comp set 1, there's 18 here and there's 18 there. So we expect that answer to be true. So let us see whether the test value, let's see what the test value gives us. Test value, the answer 5.5 is that's true. What about test? Test is also true. So this is true, and that's also true. So you can do other tests as you choose. And now from here again, as before, nothing new here. It's just that instead of names of Nobel laureates or books in the library or authors, we're just checking numbers here. So if you do that, it does the numbers, does the circles, and it does the showing. And as we noted before, I have to look for my drawing where it is. So this is the figure. This is the figure of the two sets now. Whereas these are the numbers that are common to both of them. There's no containment here. They are just there's intersection, and there are sets that are part of the sets that are outside the intersection in both ways. So again, this is another simple example that you can do for yourself. But here we have now introduced not only discrete values, but we have also now introduced continuous values. Continuous values, even though you are doing between 0 and 20, it now is looking at all the infinite number of elements. So you can see that when we are talking of sets here, we were used to sets with finite values. Now we can see sets that have infinite values that are defined with an interval. So that's the thing. So this particular set is interval sets, and Python can do interval sets. So that's what we are doing here. We'll see more in the next example. Let us go further. Unions and intersection of intervals. Sets, as we have seen, can involve discrete elements, comprehensions, as well as intervals. The above course demonstrates how this can be put together to create discrete and continuous sets. We can use the same set relationships such as unions, intersections for operations on discrete and continuous sets. Simple results of union and intersection are shown. So this code, you will see that if you use portion and interval set, you can have two intervals, you can have these three intervals, and then you can now talk of the union between 1 and 2, and it gives you this. You can see the result again. You can run this code. I won't go to run this code. These are the kind of results you will see to give you the union, it will give you the intersection, and to give you everything you want, and check whether something is in the interval. So these are interval sets. Now we can take a look at a school-sat question. This is an objective question in SSC 2006. This question was of interest to me because the question goes like this. If P is such that X is between 1 and 6, if you look carefully, you will see that this is a closed interval because it is plus or equal at the lower end, and it's also plus or equal at the upper end. So that means that the intervals are contained. Similarly, here 2 is 0 between 2 and X is between 2 and 9. This is an open set, an open interval, because there's no equal on this, there's no equal on this. Now, if you are looking for the intersection of P and Q, the answer you get depends on whether you are taking this as a set of integers or a set of or an interval set. If you take it as a set of integers, this one just is 1, 2, 3, 4, 5, 6, and this one is 3, 4, 5, 6, 7, 8. So these are discrete. If you want to treat it as discrete, which is actually what I think the question was expecting, but they use the language of intervals, which is where I say if this is real, Python can do it in any way you like. You can do it as, if you want to do it as integers, as discrete, then you can use comprehensions. So if you use comprehensions, this is the thing. You can take a comprehension iota for iota in the range 1, 7 will give you this, because the range 1, 7 includes 1 and 6. And then if you are looking at this other one, you have to go from range 3, 9 will give you this, because range 3, 9 avoids 2, and the 9 there also avoids 9. So this is range 3, 9 that avoids this. Remember that even though this is between 2 and 9 open, you cannot use 3. You cannot use 3 and 8, because if you use 3 and 8, it will also avoid 8. So these are the two things that create this P and Q as discrete. This interval P and interval Q create the two again as intervals. So you can get the intersection if they are intervals. You can, if there is an interval, you can also get the intersection if they are discrete. All of this happen, and these are the answers that you. Okay, is that the answer now? Yes, interval. Yeah, this is the answer here, and this is the answer here. So you can test this out, and Python can be used to answer this question, both as discrete as well as continuous. So the open set 2, 6 is open at one end. It's clearly the same as 3, 4, 5, 6. And if you look at it, you can see it's 3, 4, 5, 6. And maybe I should just run the code, and then maybe we can say a little bit more on it. Let me just move to the code here. This is the code. I want to first of all stop debugging and then start debugging again. And then we are debugging the Python code inside the, okay, so we do that. Now, first of all, the interval set 1 is closed. So you can see the interval is closed 0, closed at 20. The second one is open closed, so it's open at 4 and closed at 27. The third one is closed at 13 and closed at 35. And then here the interval union is this. So if you look at the interval union interval, you see is 0 to 27. So if you do the intersection, the union of these two is 0 to 27, and it is closed in both cases. So if you want to get the intersection of the two sets, the intersection of the two sets is what you see here, and the intersection, that is intersection of sets, is just 13 and 20. So if you want to check whether the answer, whether 5.5 is in intersection V set 2, that is in integer set V2, so you can check that that is going to return true. So that the answer there is true. So you can put some other things there. So these are examples of intersection where the thing is where it is not discrete. We have already looked at an example that it's discrete here. So that is one of the example we can look at. So I want to go back to our program now, and this is another objective test. We can see, okay, out of 90 scientists and Nobel laureates, 56 have won Nobel Prize, while 50 are great scientists. These are a question in SchoolSat. So we have a situation where 56 are in one set and 50 are in the second set. Okay, most of whom lived before the institution of the prize and did not win it. The probability that a scientist is chosen at random would be a Nobel laureate winner. So if we use the we just use the relative frequency now. So we showed last week that the number of elements in S plus the number of elements in T is the same thing as the number of elements in the union plus the number of elements in the intersection. So if you already know the number of elements in S and you know the number of elements in T, now, so what do you want? The total number in the union, and we know the total number is the union, and then we also know the individual groups. So what do we have here? There are 90 scientists and Nobel laureates. So that is the intersection, that is the union. So the union is the 90 scientists and Nobel laureates, 56 has won Nobel Prize, and 50 are great scientists. So if you have 56 who have won the Nobel Prize, and the second one, 50 that have won the Nobel, and then, sorry, 50 that are, okay, 56 have won the Nobel, and 50 are great scientists. So you have 56, 50 here, and then minus 90. So that gives you the intersection coming from this very explicit formula. Remember, we talked about this formula last week. So go back and look at this formula. So 16 is what you have now in the intersection there. So the Nobel number, if you do the subtraction here, you have 40. And if you do the non-Nobel, you have 34. So that is the way the thing. So the probability in this particular case will just be the probability we are looking for is just 40 over 90 here, because 90 is the total number that you have in the union. This is another example. You can see that most of the SchoolSat examples are just depending on your understanding of this formula. So if you understand this formula well, most of the issues that you have are going to be solved. Again, we just use the same figures of 90 students in a class. Each of the 90 students in a class speaks Igbo and Hausa. If it's 6 students speak Igbo only and 50 are Hausa only speakers, find the probability that the student selected at random speaks Igbo only. Again, if you just want to first of all find the number of students, you can see that the intersection will just be this. We use exactly the same figures as we did for the Nobel laureates. So the answers are exactly the same. So if you want to justify this, you don't need to worry about this again, because we've done this we've done much of this last week. So this is not a formula to memorize. This is a formula to fully understand. And if you look at the example we did last week, let me just try and remind those who have forgotten where we did it. We did it here. So if you remember on page 47, on slide 47, we've explained why that formula is the way it is. This formula is coming from that example. You can use any other example to check it out. Okay. So we don't need to spend any extra time to do the justification here. So at this point now, we can talk about the complement of a set. Okay, sorry, before we get to the complement of a set, we took out the universal set. The concept of a universe or a set that contains everything is useful in set theory and analysis. We say a universe. Let U be the universal set. It follows immediately that any set A is a subset of U. If U contains everything, then subset A is a subset of U. Consider now a set B defined as comprising of all elements that are not members of A. So if you comprise elements that are not members of A, so B is such that X is not in A. Clearly sets A and B have 0 elements in common. For instance, if B is what is not in A, and A and B now constitute U, so they are disjoint. Clearly A and B have 0 elements in common, therefore they are disjoint sets. So one of them is the complement of the other. So if X is A and X is not in B, also X is not in A implies X is in B. So if X is in A implies X is not in B, and if X is not in A implies X is in B. We are stating in mathematical symbols the simple fact that if an element is in A, then it's not in B. And equally true is the fact that if the element is not in A, then it is in B. From the above, the intersection between A and B, that is the element shared between the two sets, is the empty set, containing no element. We express this in symbols. A intersection B is the empty set. Set B, as we have defined it here, is called A prime, which is the complement of A, the set A. Now, that is what happens when we talk about the universal set. But in practical terms, what do we really mean by a universe? The concept of a universe or a set that contains everything is useful in set theory and analysis. This is true. However, you are usually concerned with everything in specific contexts. For instance, if we are in transportation, then everything means all transportation equipment that we have in mind. For instance, we might be talking of motor cars, boats, planes, and so on. If our context is transportation, we are only talking of transportation modes and transportation equipment. That's all. If our context is food, everything will mean food items. So if we are talking of what we are wearing, everything therefore means wearables. So you take the word everything and universe with a pinch of salt, because when we say everything in set theory, we are meaning everything in a particular context. So don't just think that everything is everything in this world. No, it depends on the context that we are. For instance, if we are in your school and we say everybody, we might be talking of all the students. So that would be the universal set, maybe all the students. If we are in Nigeria, we are talking of everything. We are talking of the entire population. If we are talking about road safety and registration of vehicles, we may mean every registered vehicle on the road. So let us be careful what we mean by everything. So once we have identified our universe, any set in that universe, and the things that are not in that set form the complement of that set in that context. So let us just be careful that we know what is a universal set. What's the realistic universal set depends on, are we talking of transportation? Are we talking of food? Are we talking of what we are wearing? Are we talking of a crime database, which means all the criminals in the country? So it depends on what we mean, what the context we are speaking on. The order of elements, equality. One important property of a set is that it makes no difference how the elements are arranged in the set. Say that your handbag contains your comb, mirror, and pen is exactly, in set language, the same thing as saying the bag contains a pen, a comb, and a mirror. So the order in which you put things in a bag, they are all in the bag. That's what matters. So the arrangement, when we are dealing with sets, the order of elements is irrelevant. So the order does not matter. And once you have defined a set in Python, the order in which the elements are in that set is irrelevant. Therefore, the equality of two sets is fully determined purely on membership and not on the order of membership. Two sets are equal if their members are the same. Different sets. Given set A and B, let us say we write set A and B in this Venn diagram where this is almost a circle, this is a full circle. Given set A and B, the set of elements that are present in A but absent from B belongs to the different set. So set A minus B is the set occupying this place that we have. Sorry, set A minus B is the set occupying where we have painted blue here. Whereas set B minus A is the set of elements occupying where we have painted, is it yellow now or what? Something that looks like yellow here. I don't know whether it's yellow. If it looks like yellow to you, fine. Okay, so the Venn diagram shown here demonstrates the different sets. Observe immediately that the set difference is not a commutative operation. So set A minus B is not the same thing as set B minus A. It's not even the opposite. It's not negative of it. So notice that this is not this difference between sets. It's not a commutative operation, and it's not even a negation operation. So you can see that you are talking about vastly different sets when you talk of A minus B as distinct from B minus A. Looking closely at the Venn diagram here, we can see that the number of elements in the union can be seen to be the sum of elements in the two differences and added to the elements in the intersection. So that means that if you take the number of elements in A minus B and add it to the elements in B minus A, it is simply the number of elements in the union minus the number of elements in the intersection. You can see that, again, this is something, many times the formulas in set theory can always be arrived at by just making a simple intersecting Venn diagrams, and you can see it. So do not attempt to memorize these formulas. Be able to always derive them by just sketching them out, and you'll see that it's a better way than to just be memorizing things. So this, you can see this is obvious from here. You can see that this is this one, this is this one, and you can see that it is this. If you take the total number, it's the same thing as the number in the union minus the number in the intersection here. As we previously observed, since A minus B is not the same thing as B minus A, there's supposed to be a number here. The number of elements in A minus B will not be equal to the number of elements in B minus A. N is supposed to be here. So given the meal menus of Olu and Chike, demonstrate the above results. So what you are going to do, you are going to write code. The code in the next slide demonstrates the results. Please note the following. The A difference B evaluates to B minus A, not A minus B. A dot difference B evaluates to B minus A. The intersection operation is commutative. So A intersection B is the same thing as B intersection A. Union operation is commutative. A union B is equal to B union A. The difference operation is not commutative. A minus B is not equal to B minus A. Again, all these results can also be seen. If you just make sketches of your Venn diagram, you will be able to see when the thing is commutative and when the thing is not commutative. Choose your own sets and repeat some of these operations and test and confirm the results previously shown. So here, you can, I think I want to run this code. So the file in my own phase called set difference.py. So let me just go and run this code here. Set difference.py. Open file. Open file, set if.py. Okay, here is it. So here you see the food that Olu ate are okra, yam, beans, barley, rice, and stew. Chike did rice, ugu, apple, beans, plantains, yam, and agazi. Okay, so you have that. Now you can get the difference, this is the difference of Olu minus Chike, and this is the difference of Chike minus Olu. Remember that the difference is the thing that is inside the difference bracket that is the first thing. So the intersection is easy because intersection is commutative. So Chike intersection Olu and Olu intersection Chike give you the same thing. Similarly, Chike union Olu and Olu union Chike gives you the same thing. The first test, we now try to check whether the length of difference 1 plus the length of difference 2 is equal to the length of union 1 minus the length of intersection 1. So that is that's test 1. So this again, remember this double equal, we are checking whether this is equal to this. This is not assignment now. And if this is an operation which will return true if these two are equal, and it will return false if they are not equal. If they are not equal, then that means that the formula is wrong. If they are equal, that means the formula is right. Similarly, this. So let us run this code again with the pass and the, what do you call it now? The breakpoints are already there. So I start again by stop debugging, whatever I was doing before. I start this debugging again, and we get rolling. So if we go through this code, okay, you can see that the first thing that happens is that Olu is associated with as a reference to this first set, and Chike is associated as reference to the second set. So you get the difference one. The difference one is a set, and that is plantains, ugu, yam, apple, agazi, ugu. Difference one is plantains, ugu, apple, agazi, and yams. So if you go again, and we can get difference two is a stew, barley, okra, and yam. Okay. So here, intersection one is rice beans, and so on. So you can see as we are moving on, intersection two is there, union one is there, union two is there. So let us now see the value of test one. The value of test one is true, which means the formula is correct. The value of test two is also true, which means the second formula is correct. So T1 is, then we want to see the type of test one and two. What type are they? T1, let's see, is T1 shown? I can't see T1 here. Since I can't see T1 as a local variable, I can use my watch. Can use my watch to find it. So remove all expressions. I can come here, and the expression I want to watch is T1. Okay, T1 has the classification of bool, so it's a Boolean type. I can also check for T2. It's not yet defined, and I can also ask for T3. T3. So if there's something you want to know and you cannot find it in the local variable list, you can manually ask for it there. So if I run the code again, you can see T2 is the type of diff1, which is diff1 here is the intersection. So it's the difference between these two sets. So the difference is a set. So you can see the type is a class set. So the third one is Olu pop. That is, take one thing out of it, pop a value out of the set. That is a string. So what is in the set are strings. So pop one out of it is a string. What you get out of that is a string. So that is so what you can get, and then you are now in pass. So this is a case where you can check, you can test that formula. Test the formula and you get the answers there. I can't see my, okay, let me go back to the slideshow. I hope you can see my slide. Let me just check to be sure. Can you see my slides?
Yes, sir. It's showing now, sir.
So please answer me now. Can you see my slide? I wasn't hearing.
Yes, sir. Yes, we can see it.
Okay. I can hear you now. My loudspeaker was off. Okay, so this as we said, this we can demonstrate the above results with this which we have done. So we can also look at complements and differences given set A and the universal set U. Guess what the set A difference U would be? U minus A means. To do this, remember that this is a set of elements present in the universal set but absent from A. So this is identical to the definition of the complement. Hence, we write A complement is universal minus A. So in the 15 minutes, let's see how many minutes we have left. In the about 15 minutes we have left, we are going to look at identifiers and variables. In the last fully developed code, we can recognize the following names that we are free to select. Olu, Chike, diff1, diff2, int1, union1. All those are identifiers. These are chosen by obeying the simple rules of avoidance of keywords, and that they are essentially placeholders for the results, expressions, or for the results, expressions, and computations in an assignment. They are all identifiers. They are also called variables because we can reassign them at will, and the values they will reference is the last value assigned. For this reason, you will find the words variables used frequently when identifiers are intended. I prefer the word identifiers, but the reason why they are called variables is because they can be reassigned. In some programming languages, the identifiers can also be constants. Any invocation of the identifier after being assigned a value brings the value to the place held by the identifier. So, identifiers and variables. For example, when your code reaches the third line here, which is this line, references to Olu and Chike invoke the sets to which they were earlier assigned. By the time you reach the penultimate line in the program, the diff1 invokes the result of the earlier expression that takes the difference between the set Olu and set Chike. Identifiers and variables used this way make it easy to code our intentions in Python. So you can go over from slide 1 and identify all the variables and identifiers in the program you have already run. Observe that the debugger window on the right hand side reminds you of all your variables. Again, the word variable is often used instead of identifiers, but what we really mean, all these things are identifiers and they are variables. Okay, now let us talk of types and classes. Associated with each variable or which identifier is the type of data it stores. We've already done something like that here. When we were checking the code, what type of value is a string, so sorry, let me just go back. So we did that in the last code. That type is also called class. The type of data is stored. For instance, the type of data, if it is true or false, that kind of data is called bool. If it is a set, the class of data is set. If it is an integer, the class of data is int. If it's a float, the class of data is float. So associated with each variable is type. So apart from knowing you have a variable, you need to know what kind of variable is being stored, what type. The fact that there is always a type associated with a variable does not immediately appear important or essential. This is perhaps one of the most important things you must pay attention to in order to program a Python script or any programming language for that matter. You need to know that when you are writing a program, it's not only important to know that you have an identifier. You need to have an idea of what kind of value will that identifier store, because that is going to determine what kind of operations you can take and what kind of values it can store. And most of the things you can do with it are hidden in the type or class. If it is a type that is inherent in the language, it's called type. If it's a type that was created either by you or by a library writer, it's called a class. But the word class and type can be used interchangeably because in the way, the only reason why there is any difference is the way they are created. But there is no difference in the way they work. You see, whether you talk of class or type, how they operate is exactly the same. How they are introduced, how they are created is where the difference is. The types are the ones created by Python itself. And the classes are the ones created either by you or by a library writer whose library you are using. For instance, we have imported several libraries today. We have imported the Portion library, the Matplot library, and the Venn, all those ones. Whatever types are created in those ones are called classes. But the ones that come natural with Python, just like string, int, float, those ones are called types. But call them types, call them classes, they work exactly the same way. So it is important for you to know what type your variable or identifier is storing. So let us look at some of the types that we have already used. For instance, string literals, which is called str, we've already seen. You may have noticed that when we use string objects in our set, we always place each within apostrophes, quotation marks. When we use numbers, we do not usually do so. You will see occasions later when we can place numbers in quotation marks. But once we do that, it's now no longer a number, it's a string. Strings of characters within quotes is a type in Python. The name of the type is the keyword str, string, str, or str, str. That is a string literal. String literals. All the food items in the membership sets of Olu and GK in the code we have just seen are of the type str. These are the string literals in your code, and because they are in quotes, except for a few symbols with special meaning, you are free to place anything you like inside the quotes to make a string literal. Once you are placed inside quotes, there's no longer any danger in wrongly interpreting it as a variable or a keyword, even if the names are identical with either. Then let us now look at numeric types. Python allows for three types of decimal numerics. So it's off. They are int, float, and complex. Ints are the members of natural numbers, positive and negative, with 0 that we have already seen, from minus infinity to plus infinity, 0, 1, minus 2, minus 1, 0, 1, 2, 3, and goes on like that. Floats are real decimal numbers. We've also seen them. Complex numbers are written in the form x plus yj, where x is the real part and y is the imaginary part. If you have not done complex numbers, you can forget about this for now. You can find the type of any value of or the identifier referencing it using the type of the function. We've done this already using type in one of the codes you look at. Then maybe I should show you the code in Forgotten. See this code in lines in lines 15 to 17. That is what we did here. We check for the types of test 1. We can know the types you are using. If you don't know the types you are using, you cannot write efficient programming. So it's one of the important things for you to notice when you are coding. What is the type of your identifier? Boolean types. You already know that Boolean types will return true or false. These two values are keywords in Python and cannot be used in any other context. Identifiers whose values can either be true or false are said to be binary or bool. You know there are non-binary human beings, but here we're talking of binary or non-binary values in your program. So we're not talking of human beings now, because if it can take, in our own case, it takes true or false. That's why we say binary, not male or female. Though you can also use it for male or female or up or down and so many of those things. All you need to do is to assign, you take true as up and take false as down, that's all. This can be seen in the additional code with the watch list for the values returned by the type of function set, the function calls shown above. We see that a set, whatever it contains, is of the set type or class. So you can check all these things. These are the results of the test that we just looked at here. Okay. Types and classes. Python is an object-oriented programming language. One of the salient features of an object-oriented programming language is that you, the programmer, can define new types in addition to built-in types applied by the interpreter and the programming environment. The difference between a class and a type is not what they are, but how they were created. When the type is built-in, it's usually called a type. When it is defined by the programmer directly, imported from programs written by others, the name of such types is called class. The names such types are called is class. These two words are used interchangeably, as you can see when we ask for the type of string. It tells us it is of class string. Collection classes. The set is one collection class. We've already seen the list, the date, and the tuple. How do we tell Python about the type we are using? Python gets to know the type by inferring from the value created for the first time the type is used. Python knows, for instance, that Olu and GK are sets of strings because in the first allocation of value, a set of strings was assigned. Let us go back to show to see that. For instance, here Olu was created and a set was assigned in the arithmetic assignment, it already knows that Olu is a set because of the way you created it. This is the first time Olu was appearing, and what was assigned to it is a set of integers. So it knows. It also knows that Chike is a set. It knows that difference 1 is the difference between these two, and it knows that difference is a set because of this. So Python works by inference. It infers the types that you are using. So how do we tell Python about the type we are using? Python gets to know the type by inferring from the values created the first time the type is used. Python knows, for example, that Olu and Chike are sets of string because in the first allocation of the value, a set of string was assigned. Python knows that test1, set2 are bools. Test1 and set2 are bools for the same reason, because the first thing you assigned to it was the result of a Boolean computation or of a Boolean operation or of a Boolean expression. So Python code executes line by line. There are blocks of statements that together, these are blocks of statements that executed can be considered a compound statement. With this in mind, it is correct to say that Python code executes statement by statement. Two kinds of controls are important to consider at this point: looping controls and conditional statements. Let me see how we are doing with respect to time. I want to know whether we should stop here or go through this. I am thinking that we have had enough. I'm thinking we have had enough to chew for today. I don't want to go further than this. What I want you to do is to make sure that all the codes that we have introduced today, you don't just agree with the codes. You are going to take all the iterative examples, type them in, run them, and create your own examples as a demonstration that you know what's going on. Until you can have sufficient understanding and you can create your own example, you are still joking. Our codes will work. All our codes are tested. So the fact that you run our codes and they are tested only show that you know how to type well, that you're a good stenographer. Now, good stenography is one of the requirements of this course. If you are not a good stenographer, you cannot take this course. You must do your stenography correctly. But programming doesn't end there. That is even just the starting point. After you have, then you now look at the theory and you use it to understand why every line, every code, everything that is there, why they are there. You understand them, you understand what they do. And then to demonstrate your understanding, you can expand the code, you can change the code, you can use the code to do other things that we didn't intend. Then now you are talking. So once you do that, you have, so that by the time we are discussing the issues in that code at a later time, you can have deeper understanding. And once you do that, you are beginning to write small code. You don't start building a house from the roof. You start from the foundation. Even if all you can do is to write a 5-line code of your own and you wrote it and did what you want to do, you're already programming. So programming starts gradually. It is people who want to write complicated code the first day that will not write any code. Write simple code. It may look so simple, it may look simple, simplistic. But don't worry, Rome was not built in a day. And every house you build is built by one block at a time. A block looks so innocuous and looks so simple, but by the time you put enough of them on one another in an arrangement, you have a house, you have a building, you have a skyscraper. All of that is how it is done. But if you never learn to put one block on the other, you are trying to build a skyscraper from the roof, then you are not going to do anything. So today, let us just take a look at what we did today. Today, we introduced the dict by several examples. We show how to create dicts, how to start with an empty dict, and how to populate the dict using the for loop. So we created this dict. We created several dicts today. There's another dict here. Then we learned how to use the Venn diagram by importing from Matplotlib Venn and Matplotlib PyPlot as PLT. The PLT is what shows us our drawings. And notice from the example I saw that if you have something that filled your screen, your plot may be behind it and you'll be waiting forever. Like I was waiting. I didn't know that the plot was hiding behind until Dr. Dewumi drew my attention to it. I was wondering what was happening with my code. So the code wasn't as slow as I thought. The plot was there, but it was hiding behind the screen. So learn how to create simple Venn diagrams don't use the same colors that I have used. Use your own colors, use your own opacity control, and use your own sets, and then see the intersection, see the union, and see how they do, and be able to create not just the number of things that are in the intersection, but actually what the elements are. So that will show you. And then you saw that I made mistake by forgetting my commas, and I saw when I tried to run my program, I wouldn't have seen that. There's no way I would have seen that, but at least eventually I was able to sort that out. You know that when you don't put a comma between two strings, it won't give you an error, it will just do the two strings as one. So if that's not what you want, remember to put your commas. And then here, by this point, we did the same thing again, using this written, using AutoSlide. And here we created another Venn diagram. And then here we added set comprehensions and interval sets. In set comprehensions, we created sets of discrete numbers which are integers using set comprehensions. And then we created interval sets by using the portion library. So, but we didn't use it directly. We imported it as interval. So once we have imported it as interval, anytime interval is mentioned in the code, like all these calls to intervals are actually calls indirectly to portion. You could just import portion and then use portion in this place. But sometimes it is convenient for you to decide how the imported library will be called in your code. So you are not bound to use the name that the author used it, because you can rename it like we have done here. And then we looked at union and intersections of intervals, play with this and see how it works. And then this is looked at this objective. You check it out. And if I'm too fast, go run the code yourself. That means that you have to type it in and then make sure that it's running. And then you can now change it. To change, for instance, change this instead of greater than, less than or equal here, use less than and see what it would be. And then check this out using different examples. This is another example here, another example here. Justifying this, we did that last week. The universal set thing, the complement of a set, realistic universal set, showing you here that order of element is not important when you are looking at sets. The different sets and union, intersections and differences, this formula is something you don't need to memorize, but you must understand it. Then use the meal menus of Olu and GK to demonstrate the accuracy of that formula. And then this is how the code runs. I ran it directly live for you here. And the complements and differences, you can see some of these things here. And then identifiers and variables. We talked about this, types and classes. We looked at the built-in classes like string literals, numeric types, Boolean types. Then we talked of types and classes, collection classes, type inference, how Python knows what class we are using. And then we are now at the point of talking about controls. It's at that point I said, maybe we've had enough today, and it is 9 o'clock now. I want to thank everybody for your attention. I wish you the best rest of the week. You will be hearing from us during the week as for your assignments, and then we'll see how we go from there. So if you have questions, please send information to us and let us have more from you. See you again on Saturday.
Thank you, Prof.
Thank you. Bye-bye.
Thank you, Prof. Good night. So we'll see everyone on Saturday, 6 p.m. But still watch out. We'll be sending emails to you because, of course, we have some things that you have to do before Saturday. So just watch out for that. Thank you, Prof. And thank you, everyone.
Bye-bye.
Bye-bye. Admin, you can end the meeting.
Okay, ma.
Thank you.